Hey, what's up folks? Welcome back to another layer by layer. In today's video, we're going to take a look at the Darksaber. So I want to talk about the design in Fusion 360. I spent a little extra time on making sure that the structure of the components made a lot of sense. So if we look here in the browser, I have just 4 main components. The first one being the handle, and if we dive inside of that, you can see all the little individual pieces that make the handle. You got the pommel, you got the hilt, you got the guard, the emitter. There's something on the inside called the coupler, which we'll take a look at. And then of course, all of the mounting bits for the electronics, some hardware, and that's pretty much the handle. I opted to make a dedicated component for just the electronics. I call it Tronics. So you can see here that they're all imported. So we got a button, we got the Feather NRF52840 Express, a 22 milliamp battery, and a mini over speaker. So those are the main electronics there. The blade has its own component as well. So inside the blade, you can see here I have the blade and these little black covers that fit over them. And then the last piece here is the stand, which has its own pieces too. So you got a stand for the whole prop. Another thing that I found really useful to kind of maintain like some sort of order or to stay organized is if you look at the timeline as I'm scrolling through it, it's a massive timeline, but it's all of these little colors and things help me determine what it is. So if you look at the colors here, like this green color, you see here that it's all part of the stand. So that helps me quickly, the colors indicate what I'm in. So that's really cool. So if you look at all of the these little colors on the tabs here, they're like little tabs here, they all kind of have their own dedicated color. So color coding is really nice. You can turn that on and off by pulling up your design shortcuts window with the S key and then just type color, and then it's called component color cycling toggle, and you can turn that on or off. I have it on because I just like to see those colors there. So that's 2 different things. Keeping the thing organized with the color cycling, and then just making sure that my the nested components all kind of make some sort of sense. Another thing is that I got user parameters. So changing the length or the height of the hilts, the diameters, the length of the blade, wall thicknesses, all can be changed in the user parameter window. So I use these. There are not too many of them, but there's a good amount of them. Wherever I need to kind of reuse this value, I just tend to make it into a user parameter. So these were definitely helpful, and they're be really helpful for folks if they want to change the overall height of anything. So that's really neat. All right, so the next I want to talk about is like the main shape of the handle is an oval. One of the best tools I found to make the oval was to use the ellipse tool. So I'm going to go back in the timeline here right before I start making a bunch of the things, so I can really take a look at just the handle here. So here's the handle. It's really just done with a single sketch here, or at least the profile of it is. So if we go inside of it, you can see here it's just an oval, but it has 2 dimensions to it. So whenever you're using the oval tool, the ellipse tool, you can pull it up in your sketch shortcuts window by pulling up the S key and then typing out ellipse. It wants you to pick a midpoint first. So you get a midpoint, and that's really cool. And then you specify your first dimension and then the second dimension, whether you want to make it elongated or shorter is up to you. And you can see here as you're dragging your handle here, you can see how it's affecting the shape. So you get these 2 things that you can add dimensions to, and then you get a center dot. That center dot's really useful because now you can add this to the center of your grid, or use these lines, these construction lines, as a way to offset something, or really just create like mirrors and patterns. So that's a really good tool, is the ellipse tool. So when I was making the dimension for it, I figured just make it into a user parameter. So I call it the hilt outer diameter, the outer diameter of the hilt. So that's that right there. For the second dimension, I just took that same user parameter and divided it by 1.5. That way, if anyone ever wants to increase the diameter, they don't have to worry about those two individual sketch dimensions. You can just change 1. So I thought that was nice. And then the rest here are just some offsets to create some extrudes that will be patterns. Speaking of patterns, I want to talk about how I created this pattern for the hilt. So you can see here that you got these lines, and they wrap around this surface. And the best way I found to do that was the emboss feature. Huge shout out to the Fusion team for creating the emboss feature. Take a look in the description if you want more. I have a video on the emboss feature where I went through a couple of different demos, And I think I even mentioned like making props in one of them. So it's really easy to select your profiles and then just select the surface that you want to project them onto. Not project them onto, but like wrap onto. So that's how I was doing here. This sketch is what defines the profiles for the pattern. And you can see it's just a series of lines with a bunch of sketch dimensions. Speaking of the sketch dimensions, I had a user parameter set for these, so I'm able to quickly reuse them. But the real fun thing is to like play around with the emboss feature. There's a lot of little fun things that you can do in here. For example, like if you wanted to change the rotation angle, just adding like a 10-degree value here, you can see how it like starts to wrap around at an angle, which is really neat. So you can get some really interesting patterns using the emboss feature. So using that here worked out really well. And then of course you can change the effect, whether you want it to be a cut or an extrude, and then you can fine tune the offsets if you want. But because I have it centered to the grid, the alignment is perfect, so I don't need to mess with that. But that was how I was able to wrap that around. Definitely a big fan of the emboss feature. Cool. And the next thing I want to talk about is like how I was able to avoid support material for some of these features. So this feature here, if I do a cross section of the of this area here, this is where the button is panel mounted to. Whenever you're panel mounting something to a curved surface, it helps to have some extra geometry so that you can have some flush surfaces to mount things to. So for example, the button needs to be flush here, and then to secure the button, there's a hex nut and that gets fastened into the thread of the button. And then so this right here, this flat surface allows that hex nut to press to fit onto. But what I found was that when I created this geometry, if I roll back right before I do the draft, you can see here that this is how the geometry would look like. And to print that out as is would be rather challenging for the printer. It'd get pretty stringy. And then if you wanted to add supports, well, the supports would have to be at the bottom and work all the way up to the top. So a real easy way to, normally what I would do is I would add a chamfer to this. But what happens when I add the chamfer, I can't quite do the whole thing. There's always like a little bit of piece here. And then you get like these extra tessellation lines, which like I'm not a fan of. So what I found was like, you can use the draft feature. So I'll pull up the draft feature. You want to select your pull direction first, which is going to be this flat surface. And then my face that I want to draft is this one under here. So this guy here. So once I have that selected, you can play around with the angle to see if that works. And you can see that all it's doing is just pushing that that surface there. But what's cool is that surface is a curved surface. So it's able to draft that edge even though it's not a flat surface. So that was really cool. I didn't know you could do that. And this definitely saves you from having to use supports, and it prints out really well. And then I don't have to worry about the top because the top catches itself. The way that the geometry works out is that like it just kind of curves into itself, and it catches itself. So you don't need to add a chamfer there, or rather a draft. But that's one way to do it. Another thing I want to talk about is like the position of the button is defined with this sketch here. So if you go drill down into the hilt component, open up the sketches, there's this button here. And what you can do here is if you double click on that sketch, you can see here that it's just using the user parameter of the hilt height, the height of the hilt, and then subtracting it by a fixed number. So if you wanted to fine tune this, you can increase this number to push it down more. So I'm going to add 50 to that just to show you how kind of easy it is. And because of the way it's defined that way, if you do a cross-section analysis, you can see like all of the features are just going with it. So I'll bring this back to 34 just so you can see a cross-section of it moving around. And that worked out really well. So if you want to fine-tune the placement of that component, really easy to do so. So that's cool. I guess the next things I'll talk about is the actual pieces that are inside the hilt. So let me fast forward all the way to the end of the timeline so you can see all the things. Fusion, of course, has to recalculate all the stuff just because of the nature of moving around in the timeline. But in a few seconds here, Fusion will catch up, and here we are. All right, so let me do a cross-section analysis to show you all the little pieces here for the mount. I'll even hide some of the things here. All right, so you can see here, maybe don't do a cross-section analysis, just turn off the hilt and see all the pieces here. So we'll also turn off the pommel, why not? So there are 3 pieces that are fitted into the hilt, and these 3 pieces are dedicated pieces for all the electronics. So Real quick, let's talk about the electronics. I have a 3D model of like the whole feather set. So it's just 2 boards. It's the Feather NRF52840 that has Bluetooth module on it. It has CircuitPython support. And then the thing on top is a FeatherWing. It's the PropMaker FeatherWing. This has the built-in NeoPixel port. So it can do NeoPixel. It can drive NeoPixels without having to use a capacitor or any extra add-ons. And then you have RGB pins here for the RGB button, a switch, enable and ground if you want to do an on-off switch, and then a built-in speaker port. So that's really awesome. And then this right here, this little pot, little screwdriver here, is a pot for the amplifier. So you can have built-in amplifier, built-in accelerometer, built-in NeoPixel support, built-in RGB support. This is why it's called the PropMaker FeatherWing, because it is definitely a PropMaker FeatherWing. So I have this little piece here. I designed kind of a faux headers. These are kind of your low-profile headers. So you're able to fit. I was able to fit cabling through these and then route them all through there. So that ended up working really nice. So that is the 3D models of the electronics. So definitely check them out. If you want to pick them up, I have a link in the description, so you can pick up the Feather NRF52840 and of course the PropMaker FeatherWing. So you can get those 2 right now. They're both in stock, so check them out. But back over to the design, this handle here, or this holder here, is printed up in this orientation there without any supports. And then I just have these 4 mounting holes that are sized specifically for the feather. So the feather itself gets mounted to those holes with a little bit of a hex nut under there, and then screws are fitted on top here. These are M25 screws. And then you can fit another hex nut down here to the thread so that it gets secured to this little piece here. Now, one of the things I wanted to do with the feather was to have easy access to the USB port. So if I turn on the pommel and the hilt and do a cross section, you can see how it's working here. So the pommel just comes off, it just press fits out. And then with the handle in place, you can see here that the holder for the feather actually sticks out. And if you look at the cross section, you can see that I have this ledge here that's built in there just so that the feather mount cannot be fully pushed all the way in, because then you could lose it, right? So I have that little ledge there, added some chamfers to avoid supports, and then I have this ledge here which kind of allows your fingers to kind of pull out. So if you ever need to disassemble it, it's that you can still have access to it. And then the pommel hides those 2 pieces together like that. So that's how those 3 pieces are kind of working together. But having that extra geometry to prevent the actual mount from being pushed all the way in, and also extra geometry to be able to pull it out, I think was really, really nice. So that is the feather header. And it's because it's sized for a feather, you could put whatever feather. If you don't want Bluetooth, you could just use a feather M4. Or if you want to use a completely different board, like a Itsy Bitsy or a Trinket, you can rework this to fit an Itsy Bitsy or a Trinket. Yeah. So I like the idea of like having a unibody kind of mount. That's a really cool idea, but I like having them separate pieces because then you can have this be a modular design. So you can use the feather, maybe you want to use a different battery, or maybe you don't want to use the speaker. You don't have to worry about like reducing anything, just don't print it. The battery holder here is the next thing in line, and that is really simple. This is a 2200 milliamp battery. So you can switch that if you want, but it works pretty well here. And because of the shape of it, I was able to use these sides here as a way to cable management, which is really neat. So all of the cables that are kind of going through the feather, they all squeeze through these little edges here. And that actually prevents the wires from being kinked. So that works out really well when you're trying to fit everything into the handle. All those cablings get press fitted through the battery holder, and then everything just slides in really nice. The speaker here, this surface that I have selected, that's like where you print it from. So this one has a little bit of a different printing orientation, but again, no supports needed because there's no overhangs. These little edges here barely, are an issue, so they print out really nice. And then of these 2, the battery holder prints up vertically, and so does the feather. So those 3 pieces are printed a little bit different, or rather, this speaker here is printed a little bit different. So if you want to fit a different speaker, you can either just put the speaker in there, or use our mini oval speaker, which works out really well for this project. So that is the kind of feather mounts and the electronics. We talked about the button, but there it is, the button. It's panel mounted. The next thing I want to talk about is like one of the most, I think, important parts of the design is like hidden inside the hilt. And that's the piece that allows the handle to be secured to the emitter with spacing for the guard. So I put together an animation. So we'll jump over to the animation workspace, and then I'll go to the storyboard of these three pieces. So let me find where I am. There I am. All right, so this is how these pieces are fitted together. Here we go. So the first is the screw comes out of the handle, and then that allows the handle to come free from the coupler. So this is the main piece that I'm talking about. I'm calling it the coupler because it couples those pieces together. All right, the next piece that comes out is the screw on the bottom of the emitter, so that comes out. And then when those screws are out, that allows the emitter to slide off of the coupler. And then the crossguard also slides off of the coupler. So if we look at this in animation, sometimes hitting the spacebar will create an issue. So let me just switch between workspaces, go back to animation, hit spacebar again, and the bug goes away. So here you can see how the handle fits into that, then the guard, then the emitter, then the screws, and then why not rotate it? So that is a great visual way to show how these pieces are fitted together and how the coupler keeps those pieces secured together with those screws. So now that you see the animation, let's take a look at a cross-section view so you can see some of the innards of the coupler. So go back to design, reorient myself, and then kind of reorient myself. Let's do a cross-section so you can see here. So it's this blue thing in the center here. So you can see here a cross-section of the screws themselves, and you'll notice that there is like a little bit of a geometry here. This is a cavity for a hex nut. So the screw will be secured to this hex nut. You could also use a lock nut with a nylon insert. That way it doesn't unfasten itself. And so there's one here. That is what's for the handle. And then for the emitter, another screw with another hex nut there. And then in the center of the coupler is a fairly large opening, and that allows the cabling from the NeoPixel strips to feed through into the feather, or rather into the PropMaker FeatherWing. So that's a fairly big opening down in there. You could probably fit a USB cable through if you wanted to do that. But yeah, you can see here that it's actually fairly thick. So I wanted to make sure that the coupler was a thick part, because I feel like if the coupler isn't there, and the only other way I think I could do this was to like glue these surfaces together. But if you look here, there's not a lot of surface here to glue, and this could easily be the most kind of weakest part, the weakest joint of the design would be here. But because I added this internal coupler, it's now the strongest piece. This has a really strong joint. So that's really nice. And I feel like the most important piece of the design, in my opinion, is something that's hidden. So that's cool. Hopefully folks can put this together. All right, so next thing I wanted to talk about is the emitter. Now the emitter can, there's some opportunities here to make it more lit. In some versions of the Darksaber, these little squared pieces have openings in them and little diffusers to allow light to shine through. But for this design, I kind of omitted that because I'm running out of time and I'd like to release this. But you can see here that the emitter has plenty of room for the tang of the blade to fit into. And so if you wanted to make these pieces light up, you can have your LED strip kind of go through the tang, and then the wiring can start around here in the coupler. So that's definitely possible. I think maybe for a version 2, we might revisit this piece. But because it's a modular piece, you can just work on this emitter piece, and then like everything else can stay the same because it might work itself out that way. But that's the emitter piece. The next things I want to talk about is the blade. So to show how the blade is assembled, I also put together a user parameter for it. But I guess real quick, let's take a look at the blade's kind of sketch here. That way you can see that it is with the user parameter. So here's like the main user parameter here. It's the blade length. It's 670. It turns out to be like 26 inches or so. So you can modify that if you want. And then I have some other things here that define some of the angles. But with that, let's take a look at the assembly of the blade. Let me hide the sketch, and then we'll switch to the animation workspace. Here we go, and then I'll switch the storyboard right over here. Hit the home button to reorient myself. So the blade has been sliced into 2 pieces. And you can see here that there is these pockets on the center, and there are some screws and some hardware that join these together. So let me orient myself where I think looks good and then run the animation. So here you can see the screws are coming out, hex nuts come out, and then these two pieces can come free. So they join together, screws go inside, and then these hex nuts get press fitted into those little cavities. So these pockets here are fitted with these drafted angles so that you can actually maneuver your screwdriver. So I found that that was the thing. So having that degree, that angle here, and having the length a little bit longer helped to actually secure these things together. But I really like how these are mechanically secured. It's not using glue, and they line up perfectly. The blade itself is like the thickness of it. I have a user parameter for it. It's about 8 millimeters, or it is 8 millimeters, and it has this really nice chamfered edge. So now that you've seen how they join together, I want to show how they're actually printed. So I have the slicer open. This is Cura, and here's what it looks like when you kind of put it on your bed. So the profile here is a CR10 from Creality. So like a 10 by 10 by 10 print volume is like what I recommend for this. But you can see here that it won't fit on the bed, at least this bottom piece. So what I ended up doing is I ended up rotating this 45 degrees. When you do that, if you have a part that's long and narrow, you can actually get more coverage if you rotate it at 45 degrees. So you can see here, here's 45 degrees, here's not 45 degrees. So you're able to fit this piece on here just by rotating it 45 degrees. Now, when it comes to slicing, I recommend using a gyroid infill if your slicer can do that, because the pattern actually works really well for like the aesthetic of the blade. The blade in the movies, well, not the movies, but the blade in The Mandalorian and in Clone Wars, you can see that it has like these like little electricity kind of crackles, and the gyroid infill actually looks very similar to that. And then for the infill density, I dropped it down to just 8% because anything higher than that, it gets a little bit too dense. So here's a look at the preview of it. If I start stepping through the layers, you can see here how the gyroid infill, it looks organic and stuff, but like when you look at it through the edge here, it looks like electricity bolts, like lightning bolts are going through it. So that's really neat. And then when it comes to actually like the filaments, like what's a good filament, anything that's a clear PLA, or sometimes they call it natural clear PLA, or even a PETG, something that's clear, it doesn't have any pigment, would work really well because you can change the color of the blade. This is Bluetooth, and you can use the color picker in the Bluefruit app to change the Darksaber to be any color. So I wanted to make sure that that the blade wasn't white and only white. So you can use clear PLA or clear PETG or whatever filament that's clear to let the color shine through. So that's a quick look at kind of the blade, how you want to 3D print it, and why you would want to use gyroid infill or not. So that's cool. Going back over to Fusion though, I want to talk a little bit more about the actual LED strip that gets mounted in here. So I guess I could stay here. So you'll notice that there's like this channel that goes throughout the whole, length of the blade. And if you haven't figured it out yet, that's where the LEDs go. So the LEDs are mini skinny NeoPixel strips. And they're basically, you take two strips and you put them back to back. So you basically have a double-sided back-to-back mini skinny strip, right? It's a mouthful, but it fits on the inside here, so you don't have to use like the special side lit LEDs. They just get stacked in the center of this channel. And then what I had to do to insulate those two strips from bridging each other is just to have a little piece of material sandwiched in between them. Whether it's paper or plastic, you can fit something that's really thin and put strips, or you could use Kapton tape to insulate those pads, because there are solder pads on the back of the NeoPixel strips, and you just want to make sure that when you put them together they don't touch, because they will bridge. So you just gotta have something to insulate those two. But you can see here that the channel goes all the way through the tang. It does this little bit of an angle, and then it goes straight across through the pockets. So you can see here that the LEDs just go right through that, and they start to curve and bend a little bit here to follow the tip of the blade. And then the tip of the blade here, you can see it rounds off there nicely, so it prints out nice. But that's a look at the thing. And then down here in the tang, you'll see that there's another hole here and a cavity for a hex nut. So let me jump back to the design, and then we'll look at a cross-section look at the tang here. So analysis, and then rotate around it here. Yeah, so you can see here that there's another screw hole in the emitter. And I forgot to put the screw in there like I did for the coupler, but you can imagine the screw goes through the emitter here, and then there's a hex nut here that gets press fitted into the tang, and then that's what secures the tang. And then if you look at the emitter, there are some surfaces here that like hug onto it, so it stays once the hex nut in the screw is secured. There's no wiggle room for any of these pieces, so it has a really nice tight fit. So that's cool. I guess the last thing I talk about in the blade here is these covers. So these covers are printed as well. You could like paint the part, but you need something to cover the channel and the LEDs. You could even maybe vinyl cut this piece and just like stick it over the blade. I think that would work okay, but I printed this out. It's only 1 millimeter thick. You could probably print it even thinner, but I just wanted to make sure that it was thick enough so it would block out all of the light. And one of the things that made these two pieces, because it is two pieces, right? You got two pieces of the blade. You're going to have two pieces for the cover. What I ended up doing is I added an angle. I drafted the angle of the where the two pieces meet. That way it kind of makes the seam less noticeable. So I think that was a good approach there, because like the blade just has a straight cut, but the covers can have an angle. So I added that angle there to reduce the seam, or the appearance of a seam. Another thing I found out when I printed it straight as is like that is that when I'm joining the two covers together, because of the nature of printing, like you kind of get an elephant's foot. So the pieces don't quite join together. So what I found that's really useful is to just add a chamfer or a drafted angle so that the pieces kind of stagger on top of each other like this. So you can see that angle there. This allows the pieces to fold into each other, and then that helps to block out any light from leaking through the covers. So I thought the combination of angling it and then adding that chamfer helped out really well to kind of block out that seam and block out any lights from leaking. So just print those two out, and then the way to attach them to the blade itself is I just use double-sided tape. You could use glue, but I really like the idea of still being able to pop those covers off and fine-tune the LEDs. If you need to add more LEDs or something happens to them, you can still take it apart. So that is the blade. That's really all the things I want to talk about. There's also a stand that I put together because as I'm working with it, I need a way to kind of not take up my desk space long ways. So I got that going on, but definitely check it out. I'll have a link to all the things I talked about in the description. Thank you guys so much for watching. I think I'm going to end this one with saying, don't forget to make the force be with you. Bye, folks.